Hi again guys, today we're going to go through balancing equations, but we're going to start off by going through the answers to the questions from last lesson. So the first one is the pink task, and that says, what side of the arrow do you find products and reactants? Well, hopefully if you remember from last lesson, on the left hand side we find reactants, the things that react together to form the products which go on the right. Now the next question says, what is the formula for hydrochloric acid? And if you remember again from last video, these are things you just have to remember. You're going to have to remember the formulas of the common acids and their names. And for hydrochloric acid, it's HCl, capital H, capital C, little l. Construct a word equation for the reaction between calcium and oxygen to form calcium oxide. Well, I'm running out of room here, but I'll try and squeeze it on the bottom. The things that react together are calcium and oxygen. They're the reactants. And the things that you make, or the thing that you make, is calcium oxide, and that's the product. So it would be calcium plus oxygen, then an arrow to form calcium oxide. And then finally, the purple task. Construct a symbol equation for the formation of calcium chloride from the reaction between calcium and chlorine. So this is slightly differently worded. So we have to look at what we're reacting together, which is calcium and chlorine. These are our reactants. So calcium is Ca, chlorine is Cl2. Remember, this is a diatomic element. It exists as a pair. And then an arrow and calcium chloride. We're going to just write for today CaCl. But hopefully by the end of today's video, you'll realize why that is wrong. So we're going to focus on balancing equations. It's a little bit of knowledge from last lesson, but we're going to build upon that and find out how to put the correct numbers of each element on each side. Now the first thing we're going to do is we're going to convert this word equation into a symbol equation, because you can't balance a word equation. So the first thing we're going to do is calcium, which is Ca. That reacts with oxygen, which is O2. Remember again, it's a diatomic element. And that's going to form calcium oxide. Now if we look at this equation here, we'll see that calcium on the left and on the right has the same amount. Now if we look at this equation here, we'll see that there's one calcium on the left and there's one calcium on the right. But it's not the same story for oxygen. We've got two oxygens on the left, because we've got this little 2, but we've only got one oxygen on the right. Now that's not correct. And this is because in a reaction, you don't lose or gain atoms. They must be equal. So there's some rules for doing this. We're going to look at the rules first, and then we'll have a go at actually balancing this. So here are the rules. Get them copied down, then we'll go through some examples and I'll show you how to use them. Right, this is the first one we're going to have a look at, and this is calcium reacting with oxygen to form calcium oxide. So let's have a look how we would go about doing this using the rules we've just learned. So the first thing I like to do, and this isn't on the rules but it's a good way to start, is to put a dashed line down the centre to separate the reactants and products. Once you've done that, you can start by counting up the number of atoms on the left and the number of atoms on the right. So we have one calcium on the left, because there's no little numbers, and we have one calcium on the right. If we look at our options, we'll see there is a little number this time, and if you follow the rules, this little number tells you that it multiplies the element directly to the left by that number. So it's multiplying the amount of oxygens we have by that number, which is 2. So 2 oxygens on the left. There's no little number here, so we only have 1 oxygen. Now how do we make sure that we get the right number of oxygens on the left and the right so that it's balanced? Well, we can only add large numbers to the front of elements and compounds. So that will be here, here, or here. And we have to decide where we're going to put our numbers and what number we're going to add. So if we start by doing our oxygens, since that's the one that's unbalanced, how can we get twice the amount of oxygens on the right here? Well, if I multiply it by 2, that number will multiply everything directly to the right. So it will multiply the calcium by 2 and it will multiply the oxygen by 2. So now if we do another count up to check how many of each atom we have, on the left it stayed the same, we haven't done anything to that side, so calcium 1, oxygen 2, but this time because we've added this big 2, we've now got 2 calciums and more importantly we've got 2 oxygens. So our oxygens are now balanced, but our calciums are not balanced. So we've got to do something to this side of the equation now to make sure we get 2 calciums. And we just simply look for where we have a calcium and we add a large 2 there. The reason I'm adding a large 2 is because we have 1 calcium to start with, and if I multiply the 1 by 2, I get 2. So that changes that number to 2. And now all of a sudden the equation is balanced. I'm going to show you now some to have a go at yourself. I'd like you to try these individually, pause the video and then unpause it for the answers. Now the next one we're going to look at is much harder, but the principles are still the same. You're going to put a line to separate the reactants and products and then have a count up. You have 1 aluminium on the left and you have 2 aluminiums on the right. You have 2 oxygens on the left and you have 3 on the right. Now this one's really tricky because nothing is balanced in this equation. We're going to have to balance both the aluminium and the oxygen. Now the best place to start is probably the oxygens because that's going to be the hardest one. So hopefully if we get that out of the way, then the aluminiums should fall into place and they'll be a little bit easier. Now what you have to do is try and find something that is going to make both of these numbers multiplied by to get the same number. And I'll show you what I mean by that. If I just put a 2 at the front of here, that would multiply this to make 4 oxygens. If I put a 2 here, like I did on the left, this would multiply this oxygen here, 2 times 3, to make 6 oxygens. I'm now no way near getting my oxygens balanced. So what I need to do is think, what can I multiply the left and right by to get the same number? So if I get rid of these arrows here that we've just drawn and the numbers that we just added, what can we multiply this number here by and this number here by that will get us the same? Well, if I put a 2 on this side like I did last time, 2 times the 3, that gives me 6 oxygens. What can I multiply this side by to get 6 oxygens? Well, I've got 2. What can I multiply 2 by to get 6? So if I put 3 here, 3 times 2, that gives me a total of 6 oxygens. So the best way to do this is start by doubling one side and seeing if you can do the same or different to the other side. In this case, doubling didn't work. We doubled the right and the left and we were nowhere near. So if we double one side, see if we can change something on the other that balances it out. Now let's do a recount and check our aluminiums again. So on the left we've got aluminium 1. On the right we've now got 2 times 2. So we've got 4 aluminiums in total on the right. Remember, big 2's multiply everything directly to the right and little numbers multiply the thing directly to the left. So our aluminiums are unbalanced. How can we get 4 aluminiums on the left to match the 4 on the right? Well, like I said at the start of this example, now the aluminiums have fallen into place and it's made it a bit easier. We can just stick a 4 on the left hand side and that will multiply all of those by 4. So now we are balanced. Like I said, that one was really tricky, so you might have to go back through that and really take your time with it. We're going to try another one now. Sodium and chlorine to make sodium chloride. So hopefully you remembered what you need to do is draw your line down the centre and count up what we have on the left and what we have on the right. We have 1 sodium, on the left, and we also have 1 sodium on the right. We have 2 chlorines on the left, and we have 1 chlorine on the right. So our sodiums are balanced at the moment, but our chlorines are not. So how can I get double the amount of chlorines on the right to match the 2 on the left? Well, we're going to add a big 2 here. Remember, big 2s are going to multiply everything to the right, so that's going to multiply my chlorine by 2. So now I'll have Cl2. But remember, it's also mucked up our sodiums. It multiplies everything to the right, so our sodiums are now 2 as well. So this is not balanced. So let's have a quick recount and take it from there. On our left, we still have the 1 sodium. We still have the 2 chlorines. On the right, we now have 2 sodiums and 2 chlorines. So our chlorines are balanced, but our sodiums are not. So what can we do to the left-hand side to get 2? Well, we can multiply the sodium on the left by 2, which will double this. So now we have 2 sodiums on the left, and we're balanced. The final question here is potassium plus oxygen to make potassium oxide. So principle is the same. You put your line to separate the reactants and products and count up again. We have 1 potassium on the left. We have 2 potassiums on the right. We have 2 oxygens on the left. And we have 1 oxygen on the right. So it's kind of a bit of a role reversal. We've got 2 potassiums on this side and 1 on this side, but we've got 2 oxygens on the left and 1 on this side. So, like we did last time, let's start with the oxygens. How can I get 2 oxygens on the left here? Well, we've done this quite a few times now. To get 2 on this side, we're going to add a big 2. So that big 2 multiplies everything to the right, so it's going to multiply potassiums as well as our oxygens. So 2 oxygens now, that's fine. Our oxygens are balanced. Remember, every time you add a big number, do a recount. Makes it easy for you to follow. So potassiums on the left, we still have the 1. Oxygens on the left, we still have the 2. Now on this side, we've got 2 times 2 potassiums, so we've got 4 potassiums in total. Because this number multiplies everything to the right, so if we've already got 2 potassiums, doubling that would give us 4. And 2 times 1, so 2 oxygens. So our oxygens are balanced, but our potassiums are not. So we need 4 on the left. So just add a big 4. 4 multiplied 1 would be 4. And now that's balanced. So hopefully you get a sense of how to start balancing equations. I'm going to leave you with some questions now to have a go at. See if you can do them. And if you want any answers to them, post them in the comments and I'll try and do a worked example for you.